Hello viewers of AraaTech. Once again another crucial topic in artificial intelligence. Let's start. Fewshotzeroshot learning in artificial intelligence. Fewshot learning. Fewshot learning addresses scenarios where only a limited amount of labeled training data is available for a given task or class. Traditional machine learning approaches often necessitate extensive labeled data for effective model training, but acquiring such datasets can be challenging or costly in many real-world scenarios. Goal of fewshot learning. The primary objective of fewshot learning is to train models capable of generalizing well to new instances or classes even when provided with only a small number of examples per class. This is particularly beneficial in domains where collecting large labeled datasets is impractical or when models need to swiftly adapt to new tasks or environments. Approaches to fewshot learning. Transfer learning. Definition. Transfer learning involves pre-training a model on a large dataset or a related task and then fine-tuning it on the target task with limited labeled data. Example: pre-training a convolutional neural network CNN on the ImageNet dataset and then fine-tuning it on a medical imaging dataset with limited labeled examples to detect specific anomalies. Meta-learning. Definition. Meta-learning, also known as learning to learn, entails training a model on a variety of related tasks with new examples per task. Example: training a meta-learner on a set of classification tasks, each with a small number of labeled examples to learn transferable knowledge or meta-knowledge that can be applied to new tasks. Data augmentation. Definition. Data augmentation techniques involve generating additional training examples by applying transformations or perturbations to existing data. Example: generating augmented images by randomly cropping, rotating, or adding noise to existing images to increase the diversity of the training dataset for a computer vision task. Zero-shot learning. Zero-shot learning tackles scenarios where machine learning models are tasked with generalizing to unseen classes or tasks without access to any labeled examples during training. Unlike traditional supervised learning, where models are limited to predicting labels seen during training, zero-shot learning enables models to make predictions for novel classes or tasks. Objectives of zero-shot learning. The primary objective of zero-shot learning is to enable models to generalize to novel classes or tasks that were not encountered during training. This is achieved by leveraging auxiliary information or semantic embeddings to facilitate the model's understanding of the relationships or similarities between seen and unseen classes. Approaches to zero-shot learning. Semantic embeddings. Definition. Semantic embeddings represent classes or concepts in a continuous vector space based on their semantic attributes or relationships. Example: representing words or concepts as vectors in an embedding space using techniques like word to VEC or glove, enabling models to generalize to unseen words based on their similarity to seen words. Attribute-based methods. Definition. Attribute-based methods represent classes or objects using a set of semantic attributes such as color, shape, or texture. Example: training a classifier to predict class labels based on attributed descriptions, that is, has wings, files, lays eggs, rather than direct visual features, allowing the model to generalize to unseen classes with similar attributes. Knowledge graphs. Definition. Knowledge graphs represent structured knowledge about entities and their relationships in a graph format. Example: leveraging a knowledge graph containing information about entities, nodes, and their relationships edges to enable models to generalize to unseen classes based on their relationships with seen classes in the graph. Overall, zero-shot learning techniques empower machine learning models to generalize to unseen classes or tasks, making them applicable in scenarios where the set of possible classes is extensive, diverse, or continuously evolving. These approaches provide a means to leverage existing knowledge and semantic relationships to make predictions on novel or unseen instances.